viewers. So this video is made on the view of heat transfer application, history heat transfer application in additive manufacturing. We all know that heat transfer is a very important subject for mechanical engineering core. My volunteer third year mechanical engineering students will deliberate about this case study, which is on case study on additive manufacturing and its scope and its application and its full deliberation they will make. I expect and invite my volunteers to deliberate about the additive manufacturing transfer application.
Hello viewers, this is Hariharan, third year student, mechanical student from SNS College of Technology. So initially we are initiating the process called additive manufacturing. It is the primary thing which they have been introduced in Industry 4.0. So it is completely different from the conventional method called subtractive manufacturing or any other traditional process. So it is the one thing. We can make it as the one node. From there, we are once going to the modes of heat transfer, heat transfers like conduction, convection, radiation. So this is another node. So we are blending both the nodes like additive manufacturing. In that, we are seeing the heat transfer, how it be working on. That's the basic thing, core ideology. We will be discussing on the case study upon various applications. So while coming to application, it is used in various, like in mechanical, we have take means there are three primary things like production, heat and mass transfer. Along with that, there will be some of the fluid mechanics. So in the second thing, we are mentioning the heat and mass transfer. The application, how it the heat and mass transferring from one medium to next medium. That's the basic thing. So in that, we are mentioning about, upon the additive manufacturing process, how heat and mass are transferring. Likewise.
As Hariharan said about the additive manufacturing process, there are two approaches that is carried on the additive manufacturing process, which is top-down approach and bottom-up approach. The additive manufacturing comes under the bottom-up approach, which is the layer-by-layer process of adding the materials to form a fine product. Like our mechanical manufacturing process, in everything, the heats are formed. By the heats, the chips, which are the waste materials, the chips are built up, those are formed. And let's see how we are going to consider that in the heat transfer and changes. Let's make the changes to reduce the damages.
So main thing in additive manufacturing and subtractive manufacturing, we can lost the n number of wastage in additive manufacturing. It means that while we are processing into additive manufacturing, there is a wastage and less consumption of time, less consumption of workers as well. But the process will be like comparatively high in cost. But that will be ends to a high efficiency process. So this is the basic difference between the additive manufacturing as well as subtractive manufacturing. That's the thing.
So as Hariharan said, so coming to additive manufacturing, there is a major technique called fusion deposition modeling. So in fusion deposition modeling, we are talking about heat dissipation and heat and mass transfer. So basically, our biomedical engineering students will be studying about an 3D printing technique. It's known as a fusion deposition model. They are using a filament called a calcium filament. So what they will be done now, it's layer by layer process. Comparing to a normal polymer filament, this filament will take higher energy and higher heat. So due to it always melt. So in between that, we need to use some lubrication or else some coolant to cool down that process.
How the nozzle can like withstand those temperature, high temperature. While we are mentioning the high temperature, the heat and mass transfer will be high in nature compared to that filament. How the nozzle can withstand its temperature, also the room temperature, like this.
And it is known as post processing. There are two types of processing in this. We are a STL. Another one type of mode is called STL heat transfer. SNS. In that post processing is there. Then what they will do is smoothening process, and they will wipe with the alcohol. For what they will dissipate the heat and make that filament. Instead of we have a bone called a thigh bone. You take thigh bone, it's a big bone, and it takes almost 12 to 18 hours to print the whole. it totally takes 12 to 18 hours to completely printed over layer by layer.
Like we
It's already implemented, not over India, in some other countries it may already have. So in that we can't directly fusion apposition modeling, we directly can't take and use that. We need to post process that. We need to reduce the temperature to normal room temperature, and we need to post process that. Then only we need to use that. We need to remove the supports. There are n number of supports will be, yeah. And what types of layer we are given, and the axial where the support have been given. So we need to remove all the things, and we need to use these things to dissipate the heat.
So also lattice, lattice coordination plays a vital role in designing the sensitive parts like biomedical, medical things. They will be modeling the sensitive parts over there, like implantation of ear bone, as well as they have mentioned thigh bone. Lattice and lattice related those technologies plays a vital role in that. So these are the things. Material, how it works on means based on the material property, the application may differ upon the requirements.
Like Kishore has said, they use the additive manufacturing in biomedical engineering. We have mainly used the 3D printing in mechanical engineering field. We use technology called EBM, electron beam melting. This is the similar process how Kishore ji told, like SLS use the selecting SLS. This method it takes hours of hours of time to print, long time to print. It's the same process where we make precision parts over it. It uses our metal powder, like how metal powder is compressed into a metal bar. It takes metal powder. In the chamber we have metal powder. It uses like radiation metal, like beam. It infuses the metal inside. Even there won't be a small deviation.
It will give the precise part of the components. In like aerospace and other types of precise work, where we need a precise part, like in jets and other aerospace industries, we need a precise part to use everywhere. So as others said, what he is going to coming to say, yeah, powder is in a metal powder.
Powder bed deposition is a main thing we are using in additive manufacturing. Even this type of this can be done by like metal powder is there. Once we are designing into to make this, so there's a process called powder bed fusion. Once we are getting those powder into the particular dyes or sand particles, it can be exhibited like this process. So these are the main additive manufacturing. No wastage is held over here, right? So for this time consumption also very low, but the process, that is the main thing, main limitation in that additive manufacturing. These kind of things.
Rajwal also can join.
Sir, so far we have discussed the main parts of the additive manufacturing schemes. Whereas we are avoiding the subtractive manufacturing, and now the industries are shifting to the additive manufacturing. So in additive manufacturing, what we are going to discuss is about the heat and mass transfer. So while coming to the heat and mass transfer, in addition with the additive manufacturing, as Kishore ji said, in the fusion method, we are taking the adherence questions was how was the nozzle is used in this temperatures. So you need to select a material which will be having the properties to withstand the temperature to the filaments temperature. So that are all the processes and that are all the things which are included in the additive manufacturing as a heat and mass transfer part. So after the printing is also, the material needs some of its time to rest. So that time also some air flow is needed for that material to train itself, to set itself. So that is the heat and mass transfer playing its vital role in the additive manufacturing sectors.
Okay, concisely, can we say what is the brainstorming in this session? Talking about the additive manufacturing case study.
How heat and mass transfer, mainly you can consider heat transfer, can affect or make an impact in output of the material. As you have said, we have discussed the heat, how an nozzle can withstand within its process and upon the room temperature, how it can withstand. Upon that only we can make show that whether the output component is fine or not. So it is one of the primary things of in that we are making the case study like how the additive manufacturing can its process can affect the heat and mass transfer. Heat and mass transfer can affect the additive manufacturing.
So, please control whatever they say.
They talk about the manufacturing.
They discussed about the heat transfer on the view of additive manufacturing under the case study. So hope you deliberated a better concept for the viewer. And we are happy that we discussed about the brainstorming also along with additive manufacturing. Thanks everyone for your technical time. Thank you.
Thank you.